Hi everybody, today we're going to have a look at the area formula. And the area formula describes the amount of space within a closed shape. The area is measured in units, squared. I know we've got the important part. Initially there are three formulas that help us find the area of shapes. The area of a rectangle or square is the length times width. Of course in a square the length and the width are the same. For a triangle it's half of the base times the perpendicular height. And we'll talk about what this word perpendicular means in a minute. And the area of a parallelogram is the base times the perpendicular height. The measurements used in formula must always be in the same units. So if they're not in the same units, we have to convert them to that. And we have to make sure that we use proper working. So that means sketch a diagram if it's needed, state the formula used, substitute the relevant values for the problem, evaluate it, and make sure we state the units. So let's do one. Area of a rectangle. Well, we haven't got a diagram, so we can draw one quickly. Or sketch one. I'm not going to get my ruler out. And it's 2 meters by 3 meters. So the next thing we need to do is state the formula used. So this is a rectangle. So area equals length times width. The length is 2. The width is 3. So we can evaluate that now after we've substituted. That gives us a total of 6 meters squared. The units are meters, so the area units will be meters squared. And that's correct. Let's give it a tick. Okay, what's the area of a parallelogram that has a base of 10, a sloping height of 6, and a perpendicular height of 5? Well, let's draw a parallelogram. There we go. There's our parallelogram. These sides are parallel, and these sides are parallel. My sketch is not great. But the base is 10. 10 units of some sort. The sloping height is 6. And the perpendicular height, I said earlier I'd tell you what it is. It's a line that's at right angles to the base. And that has a height of 5. I don't think my diagram is particularly accurate, but it's enough to get the details out. So then we go area equals base times height. That equals 10 times 5. We have to be careful not to use the sloping height. We're only interested in the perpendicular height. That would be 50 units squared. So we still have to state units even though they weren't mentioned in the question. We just don't know which units they are. And I'm missing a question mark here. All right. What is the area of a triangle that has base of 60 centimeters and height of 1 meter? Well, with this one, we have to be a little bit careful because this part here is in centimeters and this is in meters. So we have to either go with centimeters or meters. I don't like working with decimals, so I'm going to make it 100 centimeters and 60 centimeters. So I now have everything in centimeters. Now, perpendicular height, that's 1 meter. And the base, oops, we need to put that in centimeters, don't we? So that will be 100 centimeters. That's this measurement here. And the base is 60 centimeters. So area equals half base times height. Half times 60 times 100. So that's half of 6,000. Need some more space. That equals 3,000 centimeters squared. There we go. And that's the area of our triangle. Now, a few harder problems. A parallelogram has area of 15 centimeters. Oh, that can't be. It would have to be 15 centimeters squared. Let's fix this up. Now it's right. Let's go back to where we were. There we go. So, parallelogram has area of 15 centimeters squared. Base is 5 centimeters. What is the height? Well, we should draw a parallelogram. Here it is. Now, we want to know the height. We know the base is 5 centimeters. And we know it has area of 15 centimeters squared. So, the area equals base times height. We know the area is 15. We know the base is 5, but we don't know the height. Now, logically, to make these sides equal, 15 on this side, we need 15 on this side. 5 times and h would be 3. Therefore, h equals 3 centimeters. Not centimeters squared, because that's not the area measurement. It's just what the height would be. So, there's one harder problem. Now, a desk is split in half for 2 students. If the desk is square, let's make a square desk. There we go. And it has 75 centimeters. And if it's square, this will be not 7 centimeters. This will be 75 centimeters too. How much space does each student have? Well, area equals 75 times 75. Oh my goodness, could I have made a harder problem for myself? Well, what's the easiest way to work this out? Well, I suppose I could just use column multiplication. 5 5s are 25, 7 5s are 35, 37. Put down a 0. 7 5s are 35. 7 7s are 49. And 3 is 52. That can't be right. I suppose it can. Add them all up. 5, 2, 6, 5. So the total area would be 5625. Half of the area would be half of that. It's not an easy one to do. So half. We'll divide 2 into 5625. Half into 5 goes twice. Bring down the 6. Half into 2 into 16 goes 8 times. Remainder 0. Bring down the 2. That goes in once. Bring down a 2, shouldn't I? Subtract. Well, this goes forever. 0. Bring down the 5. That goes in twice. Remainder 1. Put a decimal point. Put a decimal point. Bring down the 0. And 2812.5. Okay. I need to make a bit more space here. Therefore, area for each student is 2812.5 centimeters squared. If I didn't make a mistake. So here's the third problem. A triangle is painted in 2 coats of paint. So let's get our triangle. A tin of paint covers 10 meters squared. If the triangle has a 6 meter base and is 3 meters high, how many tins of paint are required? Okay, Oops. The area of the shape isn't 10 meters squared. The area of a tin of paint. So here's our tin of paint. It covers 10 meters squared. All right, so let's find out the area of our triangle first. Area equals half of 3 times 6, which is half of 18, which is 9 meters squared. Okay, so we need to cover it with 2 coats of paint. So that's going to be 18 meters. 2 times the area equals 2 times 9 equals 18 meters squared. How many tins of paint? 1 tin covers 10 meters squared. We will need 2 tins to cover 18 meters squared. You can't buy a tin that only covers 18. We'll have to get enough for 20. So the answer's here, 2 tins. And there's some examples for area of shapes. I hope that was helpful, everyone. Thank you.